This is Dr. Hayek, and in this video I'm going to talk about Lewis structures. So first, let's start by defining Lewis structure. The Lewis structure of a molecule shows how the valence electrons are arranged among the atoms in a molecule. So, in writing the Lewis structure, only the valence electrons are included. Dots are used to represent electrons. In a stable compound, atoms achieve noble gas configuration. For example, hydrogen forms stable molecules by sharing a pair of electrons. It follows the duet rule because it has 2 electrons around each hydrogen in a hydrogen molecule. Now, for the second row, nonmetals from carbon through fluorine form stable molecules when 8 electrons fill the valence shell. These elements obey what we say the octet rule. So if we have 2 fluorine, they will share 1 electron each together to form the fluorine molecule. And now you can see that we have 8 electrons around each fluorine. Now fluorine can host 8 electrons on the valence shell just because it has 4 orbitals, 2s and 3 in the 2p. Now, steps for writing Lewis structure. To write a Lewis structure, we use the following 6 steps. Number 1, find the total number of valence electrons from all the atoms in the molecule. Number 2, use a pair of electrons to form a bond between each pair of bound atom. Number 3, arrange the remaining electrons to satisfy the duet rule for hydrogen and the octet rule for the second row elements. Number 4, if any electrons are left, assign them to the central atom. Number 5, if the central atom does not obey the octet rule, check if you have to use multiple bonds, double or triple. And finally, number 6, review the formal charges and make sure they are 0 or very close to 0. So let's discuss now the first example, which is writing the Lewis structure of water molecule. So first we will start by summing the valence electrons. So we list the atoms first. We have oxygen, hydrogen, and hydrogen. Now we count the valence electrons for each one. So we have 6 for oxygen and 1 for every hydrogen. So the sum is going to be 8 electrons. Now the second step is to use a pair of electrons per bond and draw in the 2 OH single bonds. So we place oxygen in the middle and hydrogens on the edges. And we use 2 electrons to form 1 single bond. Now, step 3. Distribute the remaining electrons to achieve noble gas configuration for each atom. Hydrogen needs 2 electrons and oxygen needs 8 electrons. So from the 8 valence electrons that we have initially, we have used 4. So now minus 4 is going to be 4 electrons remaining. So these 4 electrons remaining, we should put them on the peripheral atoms. However, since the peripheral atom is hydrogen and it can hold up to 2 only, and it has 2 already, so we are going to place the remaining electrons on the central atom, which is oxygen. So now, looking at the water molecule, we can see that we have 2 electrons around each hydrogen, which means that the hydrogen is obeying the duet rule. And we have 8 electrons around oxygen. So oxygen is obeying the octet rule. I'm not going to discuss the formal charge now. I will discuss it later. Now let's discuss another example, which is writing or drawing the Lewis structure for carbon dioxide. In a similar way to what we did with water, we're going to list the atoms and count the valence electrons per atom. So we have 4 for carbon, 6 for every oxygen. The total is 16 valence electrons. Now we'll use 2 electrons per bond, so we will have 4 electrons used already. And we will distribute the remaining electrons on the peripheral atoms first and then the central atom. So oxygen needs 8 electrons to achieve the noble gas configuration or to obey the octet rule. So I have used 4, 16 minus 4, 12 electrons. Now 12 electrons, I can place 6 on every oxygen. Now if I place 6 on every oxygen, I will have 8 electrons around each oxygen, which is fine, so oxygen is obeying the octet rule. However, I will only have 4 electrons around carbon. So carbon is not obeying the octet rule, which means that this Lewis structure is not a correct one. So to fix it, I'm going to be using multiple bonds. So now I will be forming a double bond between each carbon and oxygen. So I will have 2 double bonds between carbon and the 2 oxygens, and this way I will have 8 electrons around every oxygen, and also I will have 8 electrons around carbon. So that's the correct Lewis structure for carbon dioxide. Now not all second row elements obey the octet rule. For example, beryllium can form a stable compound with 4 electrons in its valence shell only. In a similar way, boron forms a stable compound BF3 with only 6 electrons in its valence shell. Now, third row elements and beyond, they can also host more than 8 electrons in their valence shell. For example, phosphorus can form the stable PCl5 with 10 electrons in its valence shell. In a similar way, sulfur can form the sulfur hexafluoride, and it has 12 electrons in its valence shell. Now, third row elements, they can host more than 8 electrons in their valence shell thanks to the empty d subshell, which has 5 empty orbitals. So now, looking at the sulfur, it has already 6 in the 3s and the 3p, and it can host another 6 electrons thanks to the space available in the 3d orbitals. Now let's discuss another example of Lewis structure where we are going to draw the Lewis structure of triiodide I3-. In a similar way, we're going to list the atoms and count the valence electrons. So we have total of 21 electrons for 3 iodines, and we also have 1 more electron from the negative charge. Now that's going to make a total of 22 electrons. Now we're going to use a pair of electrons per single bond, so we are going to use up to 4 electrons. Now we're going to distribute the rest of the electrons on the peripheral iodine first, and then on the central if we have any remaining electrons. So now 22 minus 4 is going to give 18 electrons. From these 18 electrons, we're going to use 6 electrons per each peripheral iodine, and the remaining is going to be 18 minus 12, 6 electrons. So these 6 electrons, we're going to place them on the central iodine. Now looking at this Lewis structure, we can see that we have 8 electrons around each peripheral iodine, and we have 10 electrons around the central iodine. Now let's discuss the formal charge. The formal charge, by definition, is the difference between the number of valence electrons on the free atom and the number of valence electrons assigned to the atom in the molecule. So the formal charge is equal to valence electrons minus assigned electrons. So if we consider the example of the triiodide, now on the peripheral iodines, we have 7 electrons assigned to each iodine. So the formal charge will be 7 minus 7 is equal to 0. So the formal charge on the peripheral iodine is 0. Now on the central iodine, I have 8 electrons assigned to the iodine. So the formal charge is 7 minus 8. So that's equal to minus 1. So the formal charge on the central iodine is 1 minus. So the minus that we have in the I3 minus is located on the central atom. Now why this is important? If we take a look on the Lewis structure of sulfate ion, now there is 2 possible Lewis structure for sulfate. Now the major contributor to the Lewis structure will be the one with less formal charges. So let's take a look on the formal charges of each Lewis structure. Now let's start with the one to the left. For each oxygen we have 7 assigned electrons, so the formal charge is 6 minus 7 is equal to minus 1. So there is a minus 1 on every oxygen. For sulfur, there is a 4 assigned electrons, and thus the formal charge is equal to 6 minus 4, and the result is plus 2. So there is a plus 2 formal charge on sulfur. Now let's take a look on the Lewis structure to the right. Now there is 6 electrons assigned to the 2 oxygens with double bonds, so the formal charge on these oxygens will be 6 minus 6 is equal to 0. Now there is 7 electrons assigned on the oxygens with single bonds, so the formal charge will be 6 minus 7 is equal to minus 1. Now the formal charge on the sulfur will be 6 minus 6, since there is 6 assigned electrons, and that's going to be equal to 0. Now looking at the two Lewis structures, we can see that the one to the right, which is the one with double bonds between sulfur and oxygen, is the major contributor to the Lewis structure because it's the one with less formal charges. So do you know now how to draw Lewis structure for molecules or ions? Here are some examples. I want you to pause the video and work on them, and then continue watching to find the answers. So I assume that you paused the video and you worked on them. Now here are the answers. I hope this video was helpful to you. So please like, share and subscribe, and I'll see you next time.